Okay, in nature we have basically two types of physical quantities. One is called as a scalar, right? So scalar is the one which has, right, only magnitude. You can measure only the magnitude, like example, mass, volume, distance, speed, density, work, power, energy, length, etc. Okay, they are scalar. Then we have the second type of quantity called vector, right? Vector is a quantity which has a magnitude, and also as along with magnitude there is a specific direction, right? When a quantity measured will have its magnitude plus a direction, it's called as a vector quantity. For example, displacement, velocity, acceleration, uh, force, weight, acceleration due to gravity, uh, magnetic and electric field strengths, uh, moment, torque, etc. Okay, many examples we have. We'll see one by one later. Okay, so these are the two basic differences among the physical quantities in terms of their representation. One has only magnitude, one has magnitude plus direction. Okay, fine. Now vector, the let's go to the notation. Notation of a vector, for example, you write a and an arrow mark indicating that it is a vector. If you know arrow mark, it's a scalar quantity. If you write a right arrow mark above the name of the physical quantity, we will call it as a it's a vector quantity, right? Now vector has a magnitude and a direction. So right, direction will be denoted by some angle associated with that, right? This indicates a vector. So if you I write like this is magnitude of vector, magnitude of vector a. All right, now when we say it is a vector, right, this specific representation has to follow our xyz axis. In terms of an axis, we can measure a vector in this way. So if you represent a vector like this, say that this is vector a, right, then this total distance of this line is that line will be the total distance of that line. Total length of the line represents the magnitude and an angle theta indicated with that, right? So that theta gives you the direction, right? So length of the line is magnitude of a, that's magnitude of vector a, and angle theta indicates the direction. Now, so whenever we have two different vectors, then we need to measure the angle between the two vectors. Okay, so this is angle between two vectors. Okay, so angle between two vectors. First one, let's assume that we have a vector like this and there is another vector, say like this. Okay, this is vector a and this is vector b. So you have actually an angle right? Some angle theta. This is also equal to, I can actually represent the same thing using the following notation. Say the vector A, which was horizontal, we'll write it in this way. And there was another vector which was making some angle like this. Now I'll write that angle over here. Okay, see, just okay, there is a slight misalignment, but still anyway that works for us. Okay, this is the representation. This is still the vector A and this is still the vector B, and this is the other angle theta. Irrespective of which one you represent, both are fine. Okay, that is the angle between the vectors. Always this theta, what we are writing, will be in this range: 0 less than or equal to theta less than or equal to 180 degrees. Okay, now we'll look at the types of vectors, right? The first vector that we are going to look is called as a unit vector. Okay, unit vector has unit magnitude. Any vector that has unit magnitude, right? Any vector of unit magnitude is called as a unit vector. Right now, how we measure the unit vector? Normally unit vector is measured as n cap. That is nothing but vector A divided by its magnitude. Vector A can have any magnitude, right? Divide by its magnitude to get a unity, right? That is called as the unit vector. Okay, fine. Now let us go to the XYZ coordinate axis. So when we write the coordinate axis of this type, okay, so let's say this is the original X axis, this is the Y axis, and this is the Z axis. So there are unit vectors measured along each of the axes. It has its own unit, say unit vector along X axis, unit vector along Y axis, and unit vector along Z axis. Unit in the sense its magnitude is 1, right? So if you measure the distance from origin to this, that is equal to 1. Same thing holds good if you measure the distance from origin along this direction, that's also 1. So distance measured from origin in the along the Z axis is 1, means so the direction is indicated by X, Y, and Z axis. They are I cap, indicating the unit vector along X axis. The second one is J cap. Whenever I see a J cap, it indicates that it is a unit vector along Y axis. And then we have another vector, that is unit vector K cap, indicates that it is a vector along Z axis. So X, Y, and Z axis unit vectors are directly denoted by I cap, J cap, and K cap. So other than that, any other unit vector can be represented as N cap, right? The cap indicates that it is a unit vector. Okay, so everywhere you can see there is a cap coming up indicating that it is a unit vector, right? General unit vector is N cap, but if you are looking for a specific predefined vectors, I cap indicates along X axis, J cap indicates along Y axis, and K cap along Z axis. Okay, right. After that, the next type of vector that we want to define is called as a null vector. Null vector, it's also called as a zero vector. Null vector or a zero vector, right? So zero vector has no magnitude, right? So this is a vector with zero magnitude. Okay, zero vectors do not specify anything physically, but mathematically sometimes we get the answers as zero vectors, because when you add two opposite vectors, we'll say that it's a zero vector. That doesn't specify anything physically, but mathematically they are uh, they have some significance. Okay, then the next type of vectors are equal vectors. So two vectors are said to be equal, right? So if the two vectors have equal magnitude and same direction, then you call them as equal vectors. Okay, for example, let me write one vector and it's another vector. So this is the first one is vector A, second one is vector B. You see their magnitude is same and they are pointing to the same direction. That's why they are called as the equal vectors. Then we have parallel vectors. So the parallel represents the vectors, there are multiple vectors which are pointing to the same direction, but they are of different magnitudes, right? Vectors of different magnitudes along the same direction. This is called as the parallel vector. So let's take an example. This is the first vector. So now I increase the length of this vector. So first vector is vector A, second vector is vector B. Now we see their direction remains same, but the lengths are different. That's why they are called as parallel vectors. Okay, then we have negative or opposite, right, vector. So if two vectors are opposite in direction, you can consider them to be the one, a vector is opposite to the other, or vector is negative of other. All right, so this is the first vector. Let me denote a second vector over here. So this is vector A, this is vector B. So vector A is minus of B vector, or vector B is equal to minus of A vector. You can see that they are said to be negative. Okay, then we have coplanar vectors. So two vectors are said to be coplanar if the vectors are on the same plane, right? Whatever vectors we draw, they are coplanar, because we cannot draw some vectors which is not on the same plane. So that's why, so this is say vector A, this is vector B. Both vectors are present on the same plane of this paper, okay, or same plane of this whiteboard. That's why they are said to be on the same plane. Then there is what is called as a concurrent vectors. So this is these vectors, uh, the vectors which pass through a common point, they are called as concurrent vectors. Okay, for example, say let's consider a common point like this, and every vector you draw passes through this. For example, this is one vector, right? Then I have another vector. Okay, say this is vector A, this is vector B. Let me write a third vector, vector C. You see that every vector passes through a common point, so all these three vectors are called as concurrent vectors. Okay, fine. And then we have one more category of vectors. We call them as orthogonal. Orthogonal vectors, right? The angle between the vectors is 90 degrees. If we see two vectors that have angle 90 degree between them, so this is vector A, say this is vector B. See that there is an angle 90 degree between them, so they are said to be orthogonal vectors. Okay, now okay, let's go to the simple operation of among the vectors. So the first operation is called as addition of two vectors. Okay, now let's consider two vectors first. Okay, this is vector A, and let us say we have another vector, that is vector B. Okay, now let's say this is the point, common point. Right, now the vector A plus vector B actually follows the law of parallelogram. That is, we can draw and complete a parallelogram of this. Let me draw a line like this, and let's draw another line like this, in such a way that they are actually parallel. Okay, so if we are drawing like this, then the diagonal of the parallelogram represents the sum of the two vectors. Okay, so the diagonal, let me draw using a different color. So this is the diagonal. Okay, so this is O, say this is A, this is B, say this is R, right? So let us say that originally between A and B you had an angle theta. Okay, that is the angle between the two vectors. So now the resultant is going to make an angle, say alpha, with respect to first vector, that is vector A, and with respect to the other vector B, there will be an angle beta. Okay, alpha and beta are the angle made by the resultant with respect to A and B. So I'll call this is vector A, this is vector B, and this resultant is the vector R. Right, now how do you measure? So this is the formula to be followed. So the magnitude of this vector, magnitude R, is given by under root, this is A squared. A indicates it's the magnitude of A square plus B square, magnitude of B whole square, plus 2 times magnitude of A into magnitude of B. When we don't write an arrow mark, it indicates that it is a magnitude. Okay, into cos theta. Right, so theta is here, which is the angle between the given, this is the angle between vector A and vector B initially. Okay, now this is how you measure R. Then you can measure the angle, the position of this vector by either by using two formulas. First formula is in terms of alpha. So you can find tan alpha is equal to, this is B times sine theta divided by A plus B cos theta. Okay, otherwise you can even find the angle beta using this. So if this is equation you use, you can find alpha is equal to tan inverse of, this is B sine theta divided by, this is A plus B cos theta. First important equation. Then you can also use the tan beta formula. Okay, so this is A sine theta whole divided by, this is B plus A cos theta. So this implies you can find B if required by using the tan inverse relationship, that is A sine theta by, this is A plus B cos theta. Alright, so that's how the equations are used to, these are the equations used to calculate the sum of two vectors. Very equivalent to the sum, we can go for the next concept, that is the difference. Difference of two vectors. Okay, let us consider now the same situation where we use the A plus B, right? We are going to use A minus B to represent that. Okay, so this is, let's consider the similar situation we used earlier. So let's say that this is vector A. Okay, and we had another vector, so that is vector B. Okay, if this is vector B, I can denote minus B like this. I can write a minus B like this. Same magnitude but opposite in direction. So if say this is vector A, this is vector B, this will be vector minus B. Now if I add vector A and vector minus B, the resultant will be A minus B, right? Like the previous case, A plus B you get here, right? Now I'm trying to perform A addition of vector A with minus B, so that whatever is the diagonal that you are getting will be the A minus B. That's our ultimate idea, right? So let's finish the parallelogram first. So this is one side, this is the other side of the parallelogram. Now let us write the diagonal to this, right? So let me denote this is S, right? So vector S, that is A minus B. S vector is vector A minus vector B. So here also we can actually apply the same rule. That is, now what is the angle between A and minus B? See this angle, right? Now the angle, either you can use this or I can use the other angle, right? So if normally that is a theta, right? The angle between them, that is this angle, normally we know that this is theta, right? So this will be 180 degree minus theta. That's the angle between them. So once again I can write this angle as beta, this angle as alpha, right? Still the same, notation remains same, but equations will slightly change. Okay, so this is, so in the above equations, in the previously written equations of magnitude, right, magnitude of S, now we'll write this is root of A square, magnitude of A whole square, B square, magnitude of B square, plus, see, we are going to write this is 2 A into, this is B, magnitude of A, magnitude of B, into cos of, now the angle changed to 180 minus theta. That's the only difference. So cos of 180 minus theta is minus cos theta. Okay, so that's why this is root of A square plus B square, not plus, this is minus now. This is minus 2AB cos theta is the magnitude of the difference. Similarly, we can write the angles using the following equation. That is, tan alpha is equal to, this is B sin theta whole divided by B sin theta whole divided by, this is A minus B cos theta. So this implies if you want to calculate the angle alpha is equal to tan inverse of B sin theta divided by, this is A minus B cos theta. Wherever you have a cos theta, that term becomes negative compared to the previous equation. Similarly, we write tan beta is equal to, this is A sin theta divided by, this is B minus A cos theta. Previous equation was B plus cos theta in the denominator. This is the change. So this implies beta is equal to tan inverse of A sin theta divided by, this is B minus A cos theta. All right, so let's solve some questions. First problem, if magnitude of A is equal to 3, magnitude of B equal to 4, and theta is equal to 60 degrees, right? Find, this is vector A plus vector B, comma alpha, comma beta, comma R, right? That's A plus B, sorry. A plus B itself is R. So R annu puna baribeku. This is part A of the question. Similarly, part B of the question, A minus B vector, comma alpha, comma beta. Okay. So this means, let's go to right. So this implies, let's start with the solution now. So how do you calculate part A? This R is equal to root of A square plus B square plus 2 into AB cos theta, right? So this is root of a square. A is 3, b is 4, right? Okay, so this is 3 square 9, b square, so that is 4 square 16 plus 2 into 9 into 16 into cos 60 degree. Okay, please simplify this. One mistake aitadamma. This has to be 3 and 4 alla. This is 3, this is 4. Okay, 4.94, right? Okay, then let's calculate the angle alpha. Okay, so this is alpha is equal to tan inverse of, this is b sine theta divided by, this is a plus b cos theta. So this is tan inverse of, this is b, that is 4 sine theta, 4 sine 60 divided by, this is 3 plus 4 cos 60. Right. Similarly, now the beta can be easily calculated. Right. You can use the formula. Otherwise, it is the originally given theta minus this number. Correct. So this is theta minus alpha, because alpha plus beta should be equal to theta, right? So we can use that. So theta given is 60 degree. That is minus this number, tan inverse of 0.98. That will give you the actual answer. Right. That's the answer. Right. Similar to this, now we go for part B. I want to calculate, let's say vector S is equal to vector A minus, that is vector B. So magnitude of S is equal to root of A square, that is 3 square 16 minus 2 into 3 into 4 times cos 60. 0.707. All right, then we have ಇದೊಂದು ಒಂದ್ಸಲ ವ್ಯಾಲ್ಯೂ ಚೆಕ್ ಮಾಡ್ಬೋದಾ, ಬಿಕಾಸ್ ವಿ ಆರ್ ಎಕ್ಸ್ಪೆಕ್ಟಿಂಗ್ ಬಿಗ್ಗರ್ ದ್ಯಾನ್ ಸೇ 1 or 2. ಸೊ ವಾಟ್ ಇಸ್ ದಿಸ್ ನಂಬರ್, ಒಮ್ಮೆ ಚೆಕ್ ಮಾಡಮ್ಮ ಆನ್ಸರ್, ಯಾಕೋ ಡೌಟ್ ಇದೆ. ದಿಸ್ ವ್ಯಾಲ್ಯೂ 1, ಸೊ ದಿಸ್ ಈಸ್ root of, what is this number, 9 plus 16 is anyway 25 minus 24 cos 60. Cos 60 is half, so that is 24 by 2, 12, right? So this is root of 25 minus 12 is 13, right? So root 13 is, yeah, 3.605. Okay, right. Then now let's calculate the alpha for this case, right? So alpha equation solve change. So alpha is equal to, now tan inverse of, this is b sine theta divided by, this is a minus b cos theta equals to tan inverse of, b is 4 sine theta divided by 3 minus 4 cos theta. Theta is 60. You can substitute 60 cos 60. comes to be tan inverse of 5.656. So this means the beta is equal to, right, the angle between them is 180 minus theta, right, minus alpha, correct? So this is 180 minus theta is 60 minus tan inverse of 5.656. So 180 minus 60 is 120. 120 minus tan inverse of 5.656 is the required answer. So if allowed, you can calculate tan inverse of that number and substitute. Okay, all right. Question: magnitude of vector A is 21.9835. Magnitude of vector B is 36.9877. Okay, theta is equal to 30 degrees. So body of the question: find R equals to A plus B, alpha and beta. Part B of the question: to find S equal to A minus B, alpha comma beta. And part C of the question is to find T is equal to, this is B minus A and alpha and corresponding beta. Okay, please solve. Answering A, you will get R is equal to 60, 57. Okay, 57.09. All right, then we need alpha and beta. Okay, alpha is tan inverse of 0.362, then .362. All right, now solve part B. S is equal to 21.04. Okay, now calculate alpha and beta. 1.42. Okay, 0.43. Okay, now we have to find B minus A. Okay, so that is part C, right? B minus A, what will change? Okay, so S calculates the same way, only the alpha and beta will change, right? So in case of equation of alpha, A is replaced as B and B is replaced as A in the equation. All right, okay, find it. S, sorry, ಅದು T ಇಂದ ಕೊಟ್ಟಿರ್ಬೇಕಲ್ಲ. Okay, we'll write it as T. So find T, find alpha and also find beta. T remains 21.04. Okay, .845. B should be 845. Okay, that's how we represent, right? Sum and difference is over. Now before going further to the different types of operations, let's look at some other vector representation, that is a component of a vector. Okay, so component of vector, let's first consider a two-dimensional, then we'll go for a three-dimensional. Okay, now this is x-axis, this is y-axis. Okay, and let's denote a vector. Okay, so say this is a vector, this is our vector. Now this vector makes an angle, say theta, with respect to the x-axis. Now we can actually find out the x and y components of this vector. So in order to find the, say, x component, that is its image on x-axis, is called as x component. The same image of this vector on y-axis is considered as the y component. So we denote it in this way. So this component is Rx and this component is Ry. Okay, Rx is x component, Ry is y component. Now using the property of a triangle, we can write the cos theta is equal to Rx divided by R. It's a magnitude always. So this implies if you want to calculate Rx, x component of the vector R, it is R cos theta. Similarly, if you want to write the sine theta, this is equal to Ry by R. So this implies you want to find the y component. So this is Ry is equal to R sine theta. Okay, important. Right. Similarly, we will change now, right? Let's slightly modify. Let's say that the angle is given with respect to y-axis. So this is a first case, right? I'll write case 1. Case number 1, the theta is so this theta is with respect to x-axis. All right, at the same time, if this theta is given with respect to y, okay, this is case number 2, that is if theta is given with respect to y-axis. Okay, then let's look at the diagram now. X-axis, y-axis. Say this is the vector R. Now you see this angle is given with respect to y-axis. It's possible. So still my representation remains same. So when I want to measure the y component, I have to measure this with respect to the direction is along y-axis. At the same time, if I want to measure the component along x-axis, I should measure this component. Okay. Okay, so this is ry, this is rx. Now if you want to find r, okay, let me write the cos theta now. Like we did earlier, let's write the cos theta. Now the cos theta is, right, as per the equation, it is the adjacent divided by hypotenuse. Adjacent is ry now. So this is ry by r. So this implies, now the equation changes. Ry becomes r cos theta. And if you look at the sine theta formula, this is rx by r. So this means rx can be calculated as r sine theta. So slight modification in the equation compared to the previous case. Previous case was angle was with respect to x-axis, so rx is r cos theta, ry is r sine theta. If the angle is with respect to y, then ry is r cos theta, rx is r sine theta. Okay, problem to solve. The question is to find x and y components of the following vectors. Find x and y components of the following vectors. This is y, this is x. Now let's write two vectors. Okay, vector number 1 is this, and vector number 2 is this. Okay, so first angle, this angle is 60 degree, this angle 45 degree. So this is vector A. So this magnitude is 10, and this is vector B, magnitude is 5.8. Okay, if this is given, so calculate. AX is equal to, angle is given with respect to x-axis, so this is A cos theta, right? So A is 10 cos 60, right? So cos 60 is half, so this is 5, that is the x component of A. AY is A sine theta, right? So this is 10 sine 60, right? When you simplify, this comes to be 8.66. Similarly, Bx is equal to B cos theta. So B cos theta, this is B is 5.8 cos 45 degrees. Cos 45 is 1 by root 2. So this comes to be 4.10. Similarly, the By is B sine theta. So this is 5.8 sine 45. So for 45 degrees, sine and cos are same. So sine 45 is cos 45 is 1 by root 2. That gives you 4.10 as the answer. Okay, so when the angle is given with respect to x-axis, right, this is the technique. All right, let's move further. The next question to be solved is this. 6.75. This is 8.29. So this angle is 60 degrees. This angle is 30 degrees. So in this case, we can observe that the angle given is with respect to y-axis. So first, anyway, if you want to calculate AX, this is A sine theta. So that is 6.75 into sine 30. Right? So this is 3.375. AY is A cos theta. So this is 6.75 into cos 30, approximately 5.845. Then the bx component is b sine theta, because once again angle is given with respect to y-axis. So 8.29 into sine 60. All right, so this comes to be 7.179, and by is b cos theta, so 8.29 cos 60, so 4.145. Okay, now let's go for another equation, another problem. (13.75). This is vector B making an angle 30 degree with x-axis. This is 12.91. This is vector A making an angle 45 degree with respect to y-axis. All right, so find AX, AY, BX and BY. Okay, AX is 9.130. Okay, because angle is 45. Perfect. Five. 907. Yes. Bx is equal to 6. Ulta Bekanta. Can you check once? Because angle is given with respect to x-axis. So cos 30 is bigger. Seriala. 11.907 is bx. All right. And this is bx. Perfect. Okay. Let's move on. Now, so So far we considered all the vectors in the first quadrant. If you observe, right, everything is in the first quadrant. Angle is less than 90 always, correct? But there are problems where we see that the vectors present in second, third and fourth quadrant, where we need to apply a different the method remains same, but there will be a sign changes. So something becomes negative, something becomes positive, etc. All right, so let's solve those kind of problems now, right? So let's write the x and y axis first. So if at all we have to follow a sign convention. Okay, this is x, this is y, indicating that positive x-axis and positive y-axis, whereas this side, left side, is actually, this is the minus x, indicating that x component is negative, right? This will be the minus y-axis, indicating that the y component becomes negative. Now let us solve some problems, right, on this itself. So let me draw. See, this is, all right, normal problem which we solved. Vector a, this is 5. Say angle is equal to 60 degree. Right, now I'll go to a different vector in a different quadrant. So say this is the vector b, right? Measurement is 8 and angle is 30 degrees. Okay, then the next one is here. So this is vector c, the magnitude being 7.5 and the angle here is say 45 degrees. And another vector in a different quadrant. So this is vector d equal to 9.8 and let's say this angle is 30 degrees. Okay, now we need to find ax, ay, bx, by, cx, cy and dx and dy. Okay, so ax, ay is straightforward. Can you calculate? So what is ax? Is a cos 60, a is 5, so this is 5 into cos 60 and ay becomes equal to 5 into sin 60 because angle is given with respect to x-axis, right? The 60 degree is given with respect to x-axis. Okay, ax 2.5, 4.3. This is right. We don't have any doubt in this, right? This is straightforward. Now let's go to the b, right? First, let's normally find the x and y components. So what is bx? Can you tell me the answer for equation for bx? Just look at the angle 30 degree and that 30 degree is given with respect to x or y axis. Y axis. So we know the equation. Whenever an angle is given with respect to y axis, so let's write this. So bx is equal to the b sine. Sine, right? Angle with respect to y means bx is sine. Okay, so this is b sine whatever theta it is. So this is b is how much? 8 8 sine 30. Okay, so this is 8 sine 30. Similarly, now it's clear that I can calculate by is equal to b cos theta. So that is 8 into cos 30. Okay, so find values. Sine ಹೇಗೆ ಬರೆಯೋದು ಅಂತ ಆಮೇಲೆ ನೋಡಿ. bx is equal to 4 and by equals to 6.9. Okay, now coming to the sine. So actually sine ಅನ್ನೋದು it actually comes for every resolution, right? You resolved a into ax and ay. We have to write a sign, but it is both are positive, so we never worried about that. But now when it comes to the um, component vector that is present in the second quadrant, you see its component is along which axis? It is along minus x axis. So whenever something falls in the negative axis, the sign becomes negative. So now the bx component, what we are going to write, right, that is negative. So this is minus b sine theta, which is minus 8 sine 30. That's why it is negative, minus 4. Okay, consider the y component of b, right? What is the y component of b? It's along which axis? It is positive y-axis, correct? Y-axis, but it is positive, right? So you don't have to change the sign, it is positive. Okay, so same reason why you never worried about the sign of your ax and ay. You see the ax component, which axis? Positive x-axis. So it means it is positive non-sign barivekagila, right? So same thing, the y component of vector a falls on positive y-axis, so that's also positive. So anything comes in the first quadrant, remember both are positive, ax, ay positive. Whereas whenever a vector comes into the second quadrant, right, x component is negative, y component is positive. Okay, let's extend the same concept to the third one, that is vector c. Normally I write the components, right? Cx and cy will write normally. So normal ಬರೆಯುವಾಗ ನಾನು ಏನು ನೋಡ್ತೀನಿ, I will find out what is the angle given, that is 45 degree, and with respect to what axis? It is given with respect to y axis. So whenever angle is given with respect to y axis, simply calculate the cx is equal to c sine theta, okay, and cy is equal to c cos theta. So find out the values of c and theta, substitute 7.5 and 45. Okay, so we'll write the answer directly. So this means it is 5.30 for both of them, correct? Because 45 degree. Now I'll find out the sign. So looking at the diagram, C ಅನ್ನೋದಿದೆಯಲ್ಲ ಅದರ x component ಎಲ್ಲಿ ಬರುತ್ತೆ? Minus x axis ಮೇಲೆ ಬರುತ್ತೆ. Similarly, the y component is on the minus y axis, correct? So this means both are negative, cx as well as cy. Okay, now can you do for d? Dx and dy. Normally, I can find out that angle is once again with respect to y-axis. So this is d sine theta. This is d cos theta. Okay, this comes to be 4.9 minus 8.4. Perfect. So y-axis, y component is negative, x component is positive. All right. Okay. Right. Let's solve one more problem. Vector number 1, vector A, magnitude 6.5, angle 30 degrees. Next, this is vector B. This is 4 at an angle 45 degrees. vector C 7.3 60 degrees, vector D, this is 10.5 at an angle 60 degrees. Okay, this is X, this is Y. Find the components of each vectors along X and Y axis. Sorry, just a second. Yes. Okay, so AX equal to 3.25 5.62. Okay, then all right, all right, nice. All right, now let's go quickly go to the next concept, which is to write an equation for this vector. In the sense, we know that this has to be represented as a vector A. Okay, vector A can be straightforward, easily written in the following fashion, that is, right, whatever is the x component into unit vector along x-axis. Correct? So what is unit vector along x-axis? It is I cap. So the equation for this A is 3.25 times I cap plus the next component, that is along y-axis, 5.62 j cap is the equation of A. Similarly, you can write the equation of B as whatever is the x component into I, that is minus 2.82, including the sign. Sign annu barivekama. So 2.82 into I cap plus 2.82 into j cap. Okay, now this is vector C is equal to minus 6.32 I cap minus 3.65. Okay, minus 3.65 j cap. All right, very similarly, this D can be written as vector D is equal to 5.25 I cap minus 9.09 to j cap. All right, very simple, straightforward. Okay, so same fashion we need to write the angles. We can find out the angle, and if angle is given, we can represent the x and y component and we can write the equation. All right, now say, okay, we want to go back, right? For example, let's say if a vector is given in the following fashion, right, that is, say vector A is equal to 3.25 into I cap plus 4.97 j cap. Okay, then I need to find out its magnitude. I need to find out its magnitude, and I need to find the theta somehow. Okay, so this is the method, right? So how do you find out the magnitude of this vector? It is simply root of every term, that is 3.25 square plus 4.97 square. That is the magnitude. Why? This is because of the following reason. Let's write the coordinate. This is x, this is y, and let us say they have given a vector in this format. Okay, this is the vector. Okay, now they are saying that this vector is represented using a x component value 3.25 and y component with the value 4.97. So they are asking actually what is the magnitude of A? What is the magnitude? How do you represent magnitude? That is simply this length, right? So now I know that this is 90 degree. So horizontally distance is 3.25, vertical distance is 4.95. You can apply Pythagoras theorem, right, to calculate this distance. That's what we have done. Okay, so this measurement of magnitude of A is, say this is vector A and the length of this line itself is magnitude of A. You can calculate magnitude of A square is equal to 3.25 square plus 4.97 square, which means if you want the magnitude of A, take a square root on both sides. That gives you this equation. Okay, so please find this value now. 5.93 is the magnitude. So equation is given. I'm coming back to the magnitude of A, that is the distance, and the angle theta. Let's write this is theta, right? So theta can be found, right? I know this distance, I know this distance, which means it's a tan ratio. Okay, so this means it is okay, let's write the theta. Theta is equal to tan inverse of the AY component by AX component, right? AY component, tan inverse of Y component is 4.97, X component is 3.25. This is equal to tan inverse of 1.5.